Okay, now that we've adjusted our clock to make all of the data members private, because we don't want users to just go and tweak those data members and change them to be silly things like setting hours to be 100. Well, by doing that, we need to make some other changes to our class because we do want the users to be able to do some things. And so, for example, in an example main program right here, our main program has some problems. So let's start by running through the main program. So the first off is the first line right here is using the default constructor. Is that a problem? No, the default constructor is in the public part of our class. So the user, like the main function, is allowed to call that. What about what's going on right here? Well, here we're calling a 3-argument constructor, int, and string. Are we allowed to call that constructor? Sure, that's also in the public part of our class. We also are calling the conversion constructor here for the string. Are we allowed to call that? Yeah, that's also in the public part of our class. So this part is okay because all of these member functions, all these constructors, are part of the interface, part of the public part of the class. However, this clock to string function here, this is going to have some problems because this clock to string function is not, this clock to string function is public. This is, functions are public because it's not a member function, it's just a normal function. However, it's not going to be able to access the private data inside of my clock. This function right here is not going to work anymore. We're going to have to fix that. We're going to call this problem 1, fixing the functions that use our class. Also, we're not allowed to just set the hours and minutes for our clock anymore. We used to be able to do this, but now that hours and minutes are both private data members, you're not allowed to view or modify them. So this is problem 2 that we're going to need to fix. Okay, so once again, to repeat, what's wrong with the clock to string function? Well, the clock to string function used to look like this. It uses an O-string stream and it outputted hours, and then the clock's hours, minutes, the clock's minutes, and so forth. This worked really well when minutes, hours, period, when all of those things were public data members. But now that they're private, this function's not going to be able to use them. This function is no good anymore. It's going to break and the compiler will not let this compile. We'll fix this in a little bit. However, we're going to focus on problem 2 first. What was problem 2? Now that the user can no longer access the private members like hours, minutes, and period, we have to figure out other ways to allow the user to access that information. So what we need to do is we need to control how users are allowed to access these information, which is really nice. We can check that, when they want to change the hours, they change the hours to a reasonable time and so forth. That's really great. It means that our clock is a lot better to be used. Our clock has a lot more error checking and things like that. All good things. The big downside is all that error checking doesn't come for free. We actually have to write the code that checks for the enforcement of the rules that we want to set out. So the easiest way to handle these things are what are called accessors. Accessors are basically tiny member functions whose whole job is to allow access, controlled access, to the specific private data members. So instead of letting them access hours directly, we write a little member function that says, when you call hours with no arguments, it's just going to return whatever the hours is. If you call hours with an integer, it's going to set hours to be that integer. And we have that for hours, minutes, and period. Once again, the idea is that we're controlling how these different data members are allowed to be read from and written to. Now, one thing to note is that for C++, unfortunately, unlike some other languages, it doesn't allow an accessor method to have the same name as a data member. You can't have an hours data member and an hours member function. So what generally people do is they have all of their data members end with an underscore. So instead, all of your data members would be hours underscore, minutes underscore, period underscore, to indicate that these are data members, and so that you're allowed to have the hours member function be really nice and simple, and it doesn't need to have, get in front of it. It doesn't need to have an underscore in that name. And that's a good thing because, once again, you're trying to make a clean interface for the user. You want the user to be able to have nice names for them to call things. And if you need to have any ugliness, you stick it in the private side. That's kind of the whole point of separating the public and private. And this is also the Google standard to have data members' names end with an underscore. All right. So what does this look like? Well, generally, most of the time, you write these accessors in the header because they're such simple pieces of code. You might as well just include them in the header as opposed to going through all the trouble of declaring them in the header and then defining them in the implementation file. If their definition only takes up one line, you might as well just stick that in the header. It's simpler and easier to debug as well. So there's a couple things that I want to note here. So once again, these are accessors for the hours member function, or hours data member. And you can see here, here's the hours data member, and it ends with an underscore because now all of our data members end with an underscore. The other thing to note is that I have two methods called hours. One that takes no arguments, and the no argument one is what often is called a getter because all it does is just returns the value of the data member. See, it returns an int. Now, if you say hours with one argument, these are often called setters because they're meant to take an argument and assign that to the particular data member. And notice this doesn't return anything because its whole job is just to change the hours data member. The other thing to note is this const right here, and that's going to be the topic for the next couple of slides. What does this const mean? Alright, so quick refresher on how const works, especially with const with pointers. If you don't say const, you have just a normal variable which you're allowed to change as much as you want. If you say const in front of a type, what this means is you have a constant thing. You have a constant int here, meaning this int, constant, isn't allowed to change from whatever value it's initialized with. Now, if you say const after a pointer declaration, so I have here is a pointer to a const pointer to an int. What this means is this pointer is constant. I mean, this pointer will point at something like the address of my int. This pointer has the value of the address of my int. This pointer will always point at my int. It can't be changed to point at something else. Now, my int here is allowed to change, but the pointer itself is not allowed to change. This pointer always points at this integer regardless of what it's holding. And of course you can have a constant pointer to a constant int. Now what does this mean? It means that you have a pointer that must always point at something, but that something is not allowed to be changed through the pointer either. So it's a constant pointer because the pointer isn't allowed to change after it's initialized, and it also happens to be pointing at a constant int, meaning the thing it's pointing at isn't allowed to change either. Alright. The reason why we need to talk about this is because this, remember this pointer, that this pointer is a constant pointer. That this pointer is always pointing at the address of the object that the member function is part of. And that makes sense. Does it make sense to make this point at some other object? No, that doesn't really make much sense. You can't change what this pointer points at. Now, does that mean you can change the thing being pointed at by this? Sure, and you've actually already done that. Every time you use a member function that changes its object, it's changing the thing that this pointer points at. And that's great. However, there might be times when you don't want to let that member function change the thing that this pointer points at. You don't want to let a member function change its object. So the way that you do that is by declaring it as const. And the way that that looks is you say the return type for the member function, the name of the member function, and then you say const here, which says that this member function is const, meaning that this pointer is pointing at a constant thing. So this is how you say, hey, I'm promising that this member function will not change the object that it's part of. And this is really handy because the only member functions you're allowed to call on a const object are member functions that are declared as const. So if you have a constant clock, that clock should not be allowed to change. And so anybody trying to use the clock is only allowed to call member functions that have const in front of them, or excuse me, have const after them.